Thank you for that, Professor Satya. Ladies and gentlemen, I think I'm going to be somewhat contrarian in my remarks, having spent my entire career, 40 years, in the oil and gas industry. And I want to speak to what that industry accomplished in providing the energy that's so important for industrial development that both Professor Vijayaraghavan and Professor Jhunjhunwala mentioned. And as Professor Jhunjhunwala correctly mentioned, GDP growth is important to India, and we have to find all forms of energy, right? And I have two different perspectives, interestingly. One, of course, is the US industry perspective, which I'll talk about. So what does an oil man from the US think about the headwinds that are associated with climate change in that industry? And how does one think about that? So I'll address that first, and then I'm somewhat have a unique opportunity to talk about the Indian petroleum industry, because one of the things I did when I worked for Chevron was as the head of a licensing business. I sold technology to just about every refinery in India. I've been to all of them, Jamnagar, Mathura, Numaligarh, Bombay. And so I have a unique perspective on the Indian industry, petroleum industry, at least till about 3 years ago. So I want to talk to that. So let me start talking about the oil industry in the United States, right? So over my career of 40 years, right? We talk about tech, right? Modern technology, whether it be search engines or tech for Facebook or AI and all these other things. Well, the original tech was chemical engineers, a lot of IT graduates, developing incredible technology to take crude oil of all kinds and convert them into the fuels that we've used for the last 40 years, right? We think nothing of taking a car into a gas station and putting gasoline or diesel into it, and don't recall the fact that this gooey oil is shipped all across the world. It's unloaded in refineries, taken through the refineries, through distillation equipment, to reactors, to separation equipment, incredible catalysts, converted to the products that we've been using for the last 30, 40 years, right? Get on a plane, you get high quality jet. You take it for granted. You take gasoline for granted, right? And this is what propelled the industry across the globe for the last 50 years. And I would have slight argument with Professor Vijayaraghavan in that while the first 20 years were all about how to get the same products out of different types of crude, cheaper crudes, the last 20 years of my career were all about environmental protection, right? We think environmental protection is only carbon, because that came to light in the last decade or so. So we're all consumed by carbon and climate change, which is real, and you have to fix it. But mid-career, for me, the environmental challenge was, how do you reduce SOx emissions? How do you reduce NOx emissions, particulates? Remember the ozone layer? And I remember we sold the technology to the Mathura refinery, ordered by the Supreme Court of India in 2000, to build a hydrocracker to make sure that the Taj Mahal doesn't turn yellow because of the sulfur oxide emissions. We forget that we've always been environmentally conscious, right? They were just different things. We now make, when I joined the industry, we used to make 1% sulfur gasoline and diesel. We make 10 ppm sulfur and diesel today, right? It came about because of chemical engineering and catalysis, right? So we forget all those environmental issues that we've been tackling. And so you ask an oil industry person, what do they think about climate change? Was there some denial in the beginning? Sure, there was. At least some companies, right? Not the one I worked for. Was there some look askance at, what is this new threat? Is it real? Is there really a correlation between the carbon we put out and climate change, right? Yes, there was some of that. But rest assured, the industry that I grew up with in the US has figured this out. Yes, climate change is real. I think Professor Jhunjhunwala mentioned that we can't keep doing what we're doing. So these companies are full of bright chemical engineers, as bright as the professors and the faculty here, who work hard, they're brilliant scientists and engineers, who created what they did all these years, right, to produce the low sulfur gasoline and the diesel. And they're now rolling up their sleeves and saying, how do I tackle this new threat? Because it's real, and we can't keep doing what we're doing. So let me give you a smattering of what is it that, say, a Chevron would be doing. This is all public information, by the way. It's off their website, not saying anything out of school here. And then I'll talk about what the Indian industry is doing. So, for example, what Chevron is doing is energy management. Again, Professor Jhunjhunwala mentioned it, right? The oil industry consumes enormous amount of energy. And by 2030, they will have cut their energy consumption for their own production operations and refineries by 70%. Right? Then the methane emissions that are inherently associated with oil production will be cut by 60%. Flaring, when I joined this industry, flares were common, right? You could only fly over a refinery or an oil production site and the flares would be going. Today, flares are unheard of, right? Basically, it's extremely rare and only an emergency when you have to let out these hydrocarbons up through the stack. It just isn't done anymore. Not here, not anywhere, right? That's happened. And Chevron's also building or has built the world's largest carbon sequestration project in Australia, in Gorgon, in Barrow Island, 4 million metric tons of CO2 that are associated production from LNG, right? Australia's got some of the biggest LNG plants. 4 million metric tons of CO2 are buried in Barrow Island every year. That's the equivalent of taking off 1 million cars off the road, right? So the other thing they're also doing is beginning to put investment dollars through their venture funds into many startups. So carbon engineering to remove direct air capture, which is hard to do. Carbon clean to reduce CO2 from stack gases. That's happening. They've also signed up an agreement with a company called Raygen in Melbourne, Australia, who do exactly what Professor Jhunjhunwala said. So they have precise, highly efficient solar plants, which then they turn it into 2/3 heat and 1/3 electricity. The electricity makes chilled water and the heat is stored in highly thermally insulated tanks, and that's their way of storing energy over 10 hours at least, maybe days, right? So there's a number of things that they're doing. If you think about the downstream side, biofuels, right? There's plenty of biofuels being added. US has a 10% ethanol mandate, which is a whole other subject. It doesn't do anything for carbon. If you use corn ethanol and force 10% addition, it does zero for carbon, right? Sugarcane ethanol is a little better. Cellulosic ethanol is much better, right? But some of this is government policy, farm lobbies, you can't do anything about it. So Chevron's now making a sustainable aviation fuel. They've got a contract with Delta Airlines to make renewable jet, right? So they're making the kinds of changes they'll make. And their argument would be, and I'm speaking for them now, is this transition is not going to happen overnight. It's going to take decades for the transition. And what we need is that for that industry to work hand in hand with R&D, like places like IIT Madras, and make the changes we need to make. It's not flipping a switch, right? You can't flip a switch. It's going to take time. So let me talk a little bit about the Indian petroleum industry. As I said, there's about 23 some odd refineries. We produce, when I left IIT Madras to go to get my PhD in 1974, we were producing about 600,000 barrels a day of oil, Bombay High being a major producer. Unfortunately, today we produce about 1 million barrels a day. Thanks to Cairn Energy in Rajasthan, we have some more oil there, but not much more than that. We import 4 million plus barrels a day of oil, right? The import duty on that, the import bill is substantial for a country like India, and about 4.5 million barrels a day of refining capacity. If you listen to Mr. Vaidya, who runs IOC, which has got the largest number of 11 refineries in the country. By the way, I've been to Jamnagar, which is a 1.2 million barrel a day facility. We need 3 more Jamnagars, is what Dharmendra Pradhan said when he visited the US last, when he was still the oil minister, right? So if India has to grow, we need the developing world needs 40% more energy. Certainly electrification was one answer for power, but from a fuel point of view, right, there's a tremendous growth in demand. And so they're talking about $27 billion to add to the current capacity, which is about 4.5 million barrels a day, add another 20% by 2025 and another 20% by 2030. So this is the conundrum we face, folks, is the GDP growth that has to be fueled by energy in a transition that requires additional refining capacity to build. I'm not touching coal, by the way. Others will speak to coal. I know India is hugely dependent on coal. And I think, as Professor Jhunjhunwala said, the only hope is that we can capture the carbon from all those coal plants. But we are, I don't know, about 70% dependent on coal. So it's not going to go away easily. On the oil and gas side, right? We're going to have to build more to provide the energy for the people while we transition. Right? So what is the Indian industry doing, right? So I read articles by Mr. Vaidya again. So they are building charging stations all over the place. IOC, 10,000 charging stations in the next few years. BPCL and HPCL, another 12,000 charging stations, right? IOC has put out an RFQ for green hydrogen in Mathura and Panipat, right? Electrolytic hydrogen. So the government is mandating 50% of that hydrogen needs to be green hydrogen by 2030, which is almost impossible. I don't think it's going to happen. The government has also mandated cleaner coal plants for years, and they've had to keep pushing back the regulation because it isn't happening, right? So I don't think it'll be possible to get 50% green hydrogen by 2030, but we could go a long ways towards that, right? Especially when the cost of solar energy comes down, you can use solar to electrolyze water and make hydrogen. I think that's underway. They're also looking at biofuels in India. Unfortunately, it's been a somewhat confused and fraught policy on biofuels, which were kicked off in 2008. He mandated ethanol blending. I think we're only still a few percentage points, like 10% in the US. We're now asking for 20%, but that's not easily done because it's a food versus fuel debate. Are you going to use corn ethanol? Are you going to use sugarcane ethanol? Are you going to rob it from people who need the food? That's going to be an issue. And if you get up to 20% ethanol, you're going to have change the engines, right? And you have other issues because the energy density is lower, efficiency is lower. So those are all issues. If you look at diesel, right? Biodiesel is made from trans-esterification of sugars. Again, sugars, right? If you make renewable diesel, you can make it from waste oils or other vegetable oils. But again, you get into this food versus fuel debate, right? That's not easily done either. I think the Mangalore refinery is actually working on a cellulosic ethanol plant, first of its kind. Long ways to go. And these are small percentages, right? It's not going to get the job done. So I'll leave you with this thought that the industry that provided all the energy for all of us for decades, which was environmentally conscious and produced amazing environmentally sustainable technology, is now beset, buffeted by the climate change. They accept it, they want to change it, but they want everybody to understand that this change is going to take time and that the best engineering minds in those companies are also going to help us make the transition. So I leave you with that thought. Thank you very much.